हरिः कर्ता।
Now let's look into the another method to identify or to detect outliers, that is box plot method. So a box plot, also known as a box and whisker plot, is a graphical representation of a data set that provides a visual way to identify potential outliers. It displays a summary of data sets distribution, including information about the medians, quartiles, and potential outliers. Let's have a look at how a box plot looks and how a box plot works. So let's take some of the data points and let's plot those data points on a scale from minimum to the maximum in ascending order. So this is my minimum value of a data point. Then it goes on 20, 30, and it goes on to the higher level because I want to put them in a ascending order. So these are my data points, and I put them all in an ascending order. It starts with a minimum value of 10 and it ends with the maximum value of 390. So this is my overall data. These are my overall data points. Now, once you have your overall data points, let's take the same scale and put it on top. So begins with 10 and then ends with the 390. Okay, because whatever that falls outside this 10 and 390, I want to label them as an outlier. That's what my point of interest here. Okay, so here let me let me divide this overall data points into four categories or four sections: 25%, 25%, 25%. Okay, so the center portion, the center percentage of 25 plus 25 is called interquartile range IQ. So this 25% and this 25% is called IQR, interquartile range. And the first 25% is Q1 and second one is Q2, Q3, and then that's how it works. Okay, so now the first, this is called a minimum value. Then we have the first quartile. Then we have at the center, it's called median or quartile 2. Then this one is called as third quartile or quartile 3. Then we have the maximum value. Of course, the quartile 0 normally for the box plot would be quartile 0 is the minimum value and quartile 4 would be the maximum value, because quartiles are nothing but a values. That's it. Quartile 0, below which 0% of data points should fall, whereas maximum or quartile 4 is below which 100% of data points should fall. Okay, so quartile 0 is minimum value, quartile 4 is maximum value. In between we have quartile 1, quartile 2, quartile 3, and the range is quartile 3 minus quartile 1 is called interquartile range. And now exactly this center portion, IQR portion, is known as box. Okay, and then this is called whiskers. This portion is called whiskers, and other portion is also called whiskers. That is the reason this is also known as a box and whisker plot. This is your box. So this scale has been, this whatever scale is there, that scale has been represented and in a better visual manner so that you can make some insights out of that. If you see, it resembles that. In addition to that, they have added some more features to that so that you can make a lot of inferences from the data. In spite of if you look at the same data in tabular form, it's very difficult to make these kind of inferences, this much of inferences. Minimum you don't know, maximum you don't know. So which is quartile 1, which is median, which is quartile 3, for all these things you have to do calculation. So with this, with one look, you can get all the information from minimum, maximum, first quartile, median, and third quartile, and interquartile range, and everything. Okay, so whichever that falls. So outliers can be identified as data points that fall outside of the whiskers in the box plot, and can be further analyzed or handled based on the specific requirements of the data analysis or machine learning task. So one more time, I just want to give a complete brief about these main components of box and whisker plot. So first one is a rectangular box. Let's take a small example. Suppose we have a data set of students' exam scores in a class, okay? And you want to identify any potential outliers in the data. So in this, the box represents the interquartile range, which contains the middle 50% of data. The middle, you see that the middle 50% of data, and the data is in ascending order, and then the middle 50% of the data is in interquartile range. The bottom of the box, this is the bottom of the box. The bottom of the box or left of the box represents the 25th percentile, that's called Q1, and the top of the box or the right of the box represents the 75th percentile, Q3. And let's draw a vertical line inside the box. This vertical line inside the box, it divides data into two halves, with 50% data lying left side of this center line, and other 50% is lying right side of this center line. So that's why it's called median. Then let's draw a whiskers extending from the box. The whiskers represent the range within which most of the data points fall. The lower the whisker extends from the bottom of the box or left of the box to the smallest data point within 1.5 times the IQR below Q1. So normally this minimum value would be the lower whisker extends from the bottom of the box to the smallest data point within 1.5 times the IQR below Q1. Similarly, the upper whisker or right side whisker extends from the top of the box or right side of the box to the largest data point within 1.5 times the IQR above Q3, that's quartile 3. So plot, so then you just plot individual points outside the whiskers. So these individual points lying outside the whiskers are considered potential outliers. So now let's take one example. So box plot, box whisker plot. So we can create a box plot in Python, but we need to use a matplotlib. So for that I need to import matplotlib dot pyplot as plt. Now I need to have a similar kind of data whatever I have mentioned. Let me generate random data set. So data is equal to 10, 20, let me put it a random one, 15, 20, 25, 30, 35, 35, 40, 45, 50, 100, 200, 300, 500 and 400. So this is what my data. So this is what my sequence or list. So now I want to create a box plot for this data. Simple. Let me create a box plot for this data. So plt dot box plot and mention the, and here is your box plot. These are your outliers. That's it. So it has taken that 1.5 times, the below that it has calculated the minimum value out of the IQR and the maximum value out of the IQR and quartile 3 and quartile 1, and the whatever that falls outside this minimum and maximum values are our outliers. Okay, let me put one more value here this time, minus 333, and here is your outlier even on negative side. Yes, that's what, this tool is pretty powerful. Let me execute and see that you got the outliers on upper side as well as downside. This is negative outlier, this is positive outlier. So that's how it does. So let me add some labels so that we can have a clear picture of what we are doing here. So plt.x label, data set, and plt.y label, values, and then plt.title. And this is box whisker plot to detect outliers. And then final one, let's show it. And here is your final outlier, final box plot, which shows the outliers on both sides. Clear? Just look into it one more time. We'll play around with some amount of data, or else we'll take one more example this time. Okay, we'll take one more example. So as usual, everything has been imported. So let me create a array here, create a sample data set. So np.random, let me take the random seed 0, and data is equals to, data 1 is equal to np.random.normal, same one, and then loc is equals to 0, then scale is equals to 1, and size, let me bring it up to 100. And so that's what propositional argument, keyword argument. Yeah, data 1, and this is our data. So now let's create a box plot. Let's create a box plot. So plt dot box plot of data. So I don't want to customize much, and this is our box plot, and let me add this one, and this is our box plot. There are no outliers for this. Okay, now let's take players data, players, a real world data set. So pd.read csv, and let me bring up soccer players data. So players of, so I'll check players dot columns obviously is our attribute. So plt dot box plot, and then so players, this one I'm gonna go for the height in centimeter, and here you see that these are the clear cut you can clearly see them. There are clear cut outliers of this is actually our real world data set. There are these many outliers and these many outliers, and similarly we can do it for the weight also. Let me copy this here and paste it here, and I'm going to change this to weight. And how many outliers we'll find? Oh, these are huge outliers. Too many of outliers are here. Okay, let's take one more data. This is customers data. So customers, again, pandas dot read CSV, and this is customer segmentation and customer shopping data. So customers. So I'm gonna take the this is fine. Age. Let's go for the age here. plt dot box plot and customers age. There is no issue. Everything is properly fitted well. There are no outliers. So now let's take another data. So we'll go for the price. Okay, price, and see what will happen. Oh, there are some 1, 2, 3, 4. You got the 4 outliers. So rest all are fine. So you got the 4 outliers. Okay, let's wrap this up. Now box plot. So let me scroll up here. So in this example, the matplotlib library is used to create the box plot of a randomly generated dataset. The box represents the IQR. This one, this box, exactly this box represents the IQR. The vertical line inside the box here, it's a horizontal line. It's yellow color. This line inside the box represents the median, and the whiskers. So these are the whiskers, 2 whiskers. Whiskers represent the range within the most of the data points fall. Any individual data points outside the whiskers are potential outliers that can be easily identified using the box plot. That's what we did here.